Hello guys and welcome to a very new tutorial. Today in this tutorial we are going to take a pause from TensorFlow, and I thought that this tutorial should be before the TensorFlow video, but no problem. So in this tutorial we will explain what is the basic algorithms, where does AI comes into the picture, and then machine learning and then deep learning, so that you know the proper distinction of every area of algorithms, the machine learning as well as the artificial intelligence, where does things fit. And then we'll also talk about the basic ideology, as in how machine learning works, how deep learning works, what are the differentiation in between those. So those are the things that will work, those are the things that we will actually see in this video as well. And then we will also discuss about the shortcomings of the AI, as in what are the disadvantages of the AI approaches, as in why it's very complicated and what are the things the AI cannot do. So these are also the very important core points that we must understand before we go further to this journey. Okay, so let's get started. Now let's assume that we have a basic setting, something like this. So initially we have algorithms that sort of contains the every form of solution that we can have. Some examples are like dynamic programming, searching, sorting, greedy algorithm, backtracking. I hope that you have heard of it. And inside algorithms we have another subset that is called as the AI. So artificial intelligence is nothing but any approaches that mimics human intelligence, like logic inference, A-star algorithm, minimax, etc. And then comes the machine learning. So machine learning, another subset. Some examples that we can have is SVM, linear regression, logistic regression, etc. What are ML? We will see this later. And then inside ML we have another subset that is called as deep learning. So this is how the basic foundation works. Okay, now with that in mind, let's first of all see again the basic flow. So initially we had algorithms. So I'm pretty sure that during this journey, or in machine learning, or let's just forget about machine learning or deep learning, in general flow of your programming we have always come across algorithms, and there are several algorithms like we saw mentioned: sorting, searching, etc. But in algorithm everything is some sort of static execution. So static execution means that there is a general flow of execution. So we start with some sort of a main function, and then we have some behavior. So we first of all get the inputs, and then after that we check the necessary conditions, that whether let's say if the input are negative, then we have some other sort of things to do. If they are positive, we have other sort of things to do. Let's just, it's just less than 0. Yeah, and then here if they are negative, in this control of execution we might have several other conditions designed by looping or if else, etc. Similarly here. So the point I'm trying to make is that algorithm is some sort of static thing. So they are always fixed executions based on some logics that are predefined. So that is what actually called as an algorithm. Okay, now another inside algorithms we had AI. So this was AI, and then we had machine learning. So in AI we have several other algorithms that like A-star, etc. and etc. And then we have machine learning. So AI is any approach that mimics the human intelligence. So that means intelligence, like for example inference, right? So if you have A infer B, right? So these are some other logics that AI use, but we won't be actually going much more deeper in AI. We will simply start with machine learning. So let's first of all just see this other subset of machine learning and how is it different from AI. So machine learning, it's all about finding patterns in the data. That's what machine learning does. It simply finds patterns in the data, and according to those patterns it actually performs some sort of execution. If we have to define ML, so it's something like we solve a problem without explicitly being trained for it. So it's exactly like algorithms. It solves the problem, but we don't have like some fixed logic in it. We don't have some fixed logic in it, or like algorithm. So we don't have to explicitly train it. It will automatically learn from the data. It will automatically find patterns from the data and solves it. Now, how does ML works? Let's understand that with an example. So in very simple terms, let's assume that we have some data, right? And we have some data, and if let's say this data can be anything. Right now I just assume that they are XY coordinates, right? Now if I plot those data, and those data could be something like this, right? Now what are these crosses and circles? Now suppose the problem is that we need to find the problem is that we need to classify dogs from cats. Now what I did here, so somehow I plotted all the dogs, and those dogs are represented by these x's, and those dots, and sorry, these circles are represented by cats. So that means these circles are cats, these whites are actually dogs. Now you might be wondering, oh, how did I actually plot it in a two-dimensional plane, the dogs and the cats? So let's not get into that. We will actually explore everything in as we go along this journey. But in machine learning or in deep learning or in general, you can actually plot everything, because if you think about it, an image of dogs is nothing but there are several pixels, right? So that means, let's say the image is 20 cross 20 for example, so that means we have 400 pixels, or in other words we can simply say, so this is just one image and we have 400 features. That means every pixel is one feature. So we can plot this in a 400 dimension plane, right? So if we imagine that we have a dimension plane which have 400 axes, so in that 400 dimension plane this image would be simply one dot. So it could be either one, so this is a dog image, so it would be one cross in a 400 dimension, right? But this ain't 400 dimension, this is just 2 dimension. So somehow what I did, I sort of reduced the dimensionality to 2 dimension, and this looks something like this. And it kind of makes sense, because depending on different dogs, the crosses might be here or here or here, and similarly for cats might be here, here or here. In extremely simple terms, what machine learning does is that it sort of tries to find a boundary. So it tries to find a boundary that sort of separates those. So it after learning, it might try to find some boundary like this, and this is boundary that shows that, okay, this is actually the sort of classification. I know that whatever that is in this side, they are all dogs, and whatever that are in this side, they are all cats. Now how does it do that? How does it find this boundary? So that is what we will understand in much more detail. But that's what machine learning does. In any so this is classification. So in any, either it's a classification problem or even in a regression problem, which is another sort of problems, that we will see a little bit later. But in though that problem also, our job is to simply find a boundary that sort of summarizes the data. So here also it summarizes the data. How does this line summarize the data? Because it knows that all the points that are on the left side are dogs, all the points that are on the right side are cats. So some sort of summary is being presented by this line, right? So that's what machine learning does. As simple as that. Now another thing that I want to talk you about here. So for example, this line, so this is a line. So that means, how does, in a two-dimensional plane, how do we represent a line? Well, in simple mathematics, we know it's y is equals to mx plus b, right? So y, so something like this. So this is your, m is your slope, right? And b is your actually bias. So b is actually the bias. Now if you change b, so if b is changed, then this line goes up or down. So that simply represents the bias, and m sort of simply represents the angle. Yeah, so the m simply sort of represents sort of the angle. Like for example, m is, so if let's say y is just 2x, so y is 2x, could be something like for example, x is equals to 1, that means y is equals to 2, right? So you can plot, okay, so x is 1 and y is 2, so that means something like this. So this line would look something like this, right? What if the m was negative? So if m was negative, then you would have some this value or some sort. So you can see this m sort of rotates these line, and b sort of shifts this line above or down. So that is mx plus b. So that means to find this decision boundary in here, so we had some m and some b. Now this m and b are called as the parameters, because these parameters actually define how your model or this line would actually behave. How will this line behave? That depends on m and b, and machine learning, all it does is simply find m and b. That's it. So in general, so y is equals to mx plus b, so it's a line in two-dimensional plane, right? It's a line in two-dimensional plane. Similarly, let's say y is equals to m1 x1 plus m2 x2 plus some other constant here, like some constant like b. So it can be, so this is a line in three-dimensional plane, which is also called as a plane, right? A line in a three-dimension is also called as a plane. Similarly, we can have more dimension depending on your m, right? So we can have, let's say, mn xn plus mn minus 1 xn minus 1 plus dot 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 dot, and in the end some constant. So this is actually a line in a higher dimension plane, So that's what actually machine learning does. It simply sort of finds a line in a in a higher dimension plane. That means all it does is simply try to find the right values of m and the bias c, so that it can form these lines. So right now I just showed you here in two-dimension plane, but in general it sort of creates this line in a higher dimension plane, and that's how machine learning finds the pattern that classifies or also sort of regress. So in regression, what does regression do? Well, let me choose a different color. So again, let's say, so this we have some points, right? So in regression, what it does, we simply try to predict, right? So I suppose this is what our data is, right? So we had some points, let's say in two-dimensional plane. Now if I say that if x is equals to 10, what would be the y? Give me a proper prediction. Now for that, if I know what is y is equals to mx plus b, then if I know what is m and b, I can simply put these values here and get the y. So in here, what regression means? Regression means to find a prediction. Suppose, let's say if I find a line something like this in the general direction of the points, then I know that this line is very close to all the points, right? This line is very close to all the points. Now if I know the M and B of this line, if I place it here, then I would get a good prediction. It won't be an exact value, but it would be a good prediction for this point, right? That's what regression is all about. Regression is all about to find a line that is very close enough to all the points and that behaves as a good prediction. For a given point. So that's what called as regression. So if you think about it, whatever we do, it's mostly either we are regressing or we are sort of trying to classify some things, right? So that's how machine learning works. So as a summary, machine learning, all it does is learning the patterns by finding the decision boundary that sort of summarizes the data set, whether it's classification or regression. Now, one disadvantage of machine learning. Now, if you think about it, the general form of machine learning is actually a line, right? Now, what if, let's say I had some values like this. So some x's are here, right? And then there are some y's like here. Now in such cases I don't have a line. How do I fix it, or how do I classify it? Well, the thing is, in machine learning you can also create very complicated lines that might bend a little. That is also machine learning can do. But to do that, we need to add so much complexity in the data that it might overfit. Now you would generally see these two terms, overfit and underfit. This we will understand later what does this means. But in simple terms, overfit and underfit means bad for your model. So using machine learning, you can create some like complicated these circular lines. That means in a very high dimension, like adding multiple variables, etc. and etc. But this is where the limits of ML is, and then enters the deep learning, which are excellent in doing such jobs. Okay, now let's understand deep learning by a simple visualization. Suppose our task is to classify whether a man is happy or sad. So we use deep learning, whose core algorithm is neural network. So imagine that we have an input image, we pass to the neural network. Now the first layer actually learns some very small elements like edges, corners. Now these edges, corners are passed to the second layer, which aggregates it to form circle, square, etc. And if we keep on passing these patterns, now it forms the object itself. And then as you find the objects, it learns the mapping to finally say that the guy is actually sad. So now if you see here, that's how neural network learns. Neural network sort of have these layers, and every layer learns these basic functionalities. They simply learn that, okay, for example, in this case, in the first neural network, all it does, it simply out of the image, it learns where are the edges, where are the corners, very small things. And these small things are now passed to the second layer, which aggregates these small things to create little bit more complex things, maybe adding the edges to form circles or some squares, etc. And then these circles and squares are passed to the next layer, which aggregates them further to make a face or to make some sort of meaningful features. And similarly, that is how every layer sort of learns these patterns in a hierarchical way. And that is what the difference between deep learning and machine learning is. In machine learning, we find the patterns by decision boundary. In deep learning, we learn it using neural networks that learn this in a hierarchical way. And in the end, simply by learning, it maps that, okay, these features, they most resemble to sad rather than being happy. So that's how deep learning works. So I guess now you know what is the difference between deep learning, machine learning, and other whatnot. Okay, now with that in mind, let's understand the different fields that are out there. Data scientists, machine learning engineers or deep learning engineers, research scientists, data analysts and MLOps engineers. Now, how do they differ from each other? So let's first of all understand, before talking to it, let's understand the basic pipeline of how the things actually work. So you have your images, or let's say not images, just input. It could be images, it could be audios, it could be raw text, it could be some CSV files, etc. Right? And then you do some cleaning on it, because there might always be noise in the data, or we want the data into certain formats, etc. Right? And then you design some model, right? It could be machine learning model, it could be deep learning model. You then train the model, and after training the model you find the loss, what are the loss, and then again retrain the model to optimize the loss. And once it's done, we then let's just consider this as one block, right? And then we then check that how good or bad our model is. That means the matrix, good or bad, or in other terms I should write matrix here. So matrix simply represents how good or bad your model are, and then we interpret the results, right? So we interpret the results. So this is actually the general pipeline. Now let's come the data scientist. Data scientist actually is given a problem, and they look at the business or research problem and simply say that, can we solve this problem with this data? Can we solve this problem with given data? That's all they do. So they take the data, they clean it, they create the models, they train it, and then calculate the loss, and then they do the matrix, and then they interpret the results, all from the end to end, like stuff from the starting to the end. Everything is actually done by data scientists. So data scientists are sort of the one that actually are involved throughout the pipeline. Okay. And then comes the machine learning engineers. So what machine learning engineers do, of course they have like input, they also sometimes cleans the data. Of course they have to clean the data, but the model actually they use are sort of already pre-trained or already built by data scientists. And what they do, they actually make them fast, scalable. They make them fast, they make them scalable and also usable in the real world. So they actually don't sort of create the model, but they actually already use the model that are being developed by data scientists, and then they train the model, they deploy them, they also make sure that it works on a large scale data, not just small data, and then they optimize it to get the better results, to get better speed, to get better accuracy. And they also maintain this pipeline. Yeah, so they also sort of maintain this pipeline so that it actually works. Yeah. Tools they actually use are like TensorFlow, PyTorch, etc. And like for our case, we will be using TensorFlow, right? So that was machine learning and deep learning engineers tools. And then comes the research scientists. So research scientists are like more of geeks, as in they develop new algorithms, they develop new ML algorithms, and like research papers, they publish research papers, they actually push the field forward, yeah, so to get more advancements, etc. So they study cutting edge problems, they propose new neural network architectures, and then they work on some foundational topic like interpretability or robustness, etc. and etc. And then there comes the data analyst. So data analyst is much more on the data side. So they are much more on the data side. So they analyze the data to get the necessary trends, to get some patterns, and then they create reports out of it, visualizations like we did, in the things like in the like couple of minutes ago, they create visualization reports, etc. So the tools they actually use are SQL, Python, Power BI, Tableau, etc. And then last but not least, we also have the MLOps engineer, and they actually manage how models are deployed, monitored, and actually scaled in production. So they set up pipelines for training and retraining. They ensure that the model performance is good over time. They handle logging, rollbacks, versioning, etc. and etc. So these are actually the basic differences between all these fields, and they all revolve around these pipelines. And yeah, that's it, I guess. And now you know, like, what are these different fields, and as we keep going on this in this journey, you might also find yourself that what suits you better. Now, before ending this lecture, I also want to talk you about some disadvantages of AI. Now, the very first disadvantage is that even if it's machine learning or deep learning, we need huge amount of data. We need huge amount of data. If deep learning is not just that you can just simply train it on a small data and get a very state of the art results, you need huge amount of data, and you need huge computation as well. You need huge computation power. That means GPUs, clouds, etc. The data might be biased. So if the data might be biased, and if your data is biased, the model that you will get will also be biased. For example, let's say, I don't know, you are creating a model to detect faces, and you have in your data set you had white guys more in comparison to black guys. Then the model might be much more favorable in recognizing white guys rather than black guys, because the model doesn't know much about black guys, right? So this is, so this is exactly what bias means, and it can actually create huge problems. So these are things that we need to take care about. These are the things that we need to understand to make our model much more robust. And fourth, it's very hard to train and actually get the proper execution. So to actually get that perfect model that actually handles every situation, it's very hard, because when you have so many large parameters, it's very easy that the model underfits, overfits. So it's not an easy task to train the model, and we will see this later as we go forward with the course. So I guess that was it for today, and I hope that you understood these basic principles, these basic ideologies, and I'll see you next time. Radhe Radhe.